Hello and welcome back to yet another episode. Myself, Fazira Razak Hamza, PG Department of Computer Science, and I'm here to present on the course Principles of Software Engineering. So in the last class, we were discussing about elaboration, negotiation, and validation of requirements, which are the basic steps. So today we're going to discuss on some analysis model, or we simply say requirements analysis. Requirements analysis results in the specification of software's operational characteristics, indicates software's interface with other system elements, and establishes constraints that software must meet. So requirements analysis allows us to elaborate on basic requirements established during the inception, elicitation, and negotiation tasks that are part of requirements engineering. The requirements modeling action results in one or more of the following types of model. So let's see what are the models. The first model is scenario-based models of requirements from the point of view of various system actors. Next is data models that depicts the information domain for the problem. Then we have class-oriented models that represent object-oriented classes, attributes, and operations, and the manner in which classes collaborate to achieve system requirements. We have flow-oriented models that represent the functional elements of the system and how they transform data as it moves through the system. Then we have behavioral models that depict how the system behaves as a consequence of external events. So these models provide a software designer with information that can be translated to architectural, interface, and component level designs. So the requirements model or analysis model provides the developer and the customer with the means to access quality once software is built. Next is a figure. The analysis model thus acts as a bridge between the system description and the design model. The analysis model bridges the gap between a system level description that describes overall system or business functionality as it is achieved by applying software, hardware, data, human and other system elements, and a software design that describes the software's application, architecture, user interface, and component level structure. So throughout requirements modeling, our primary focus is on what and not how. So, what user interaction occurs in a particular circumstance? What objects does the system manipulate? What functions must the system perform? What behaviors does the system exhibit? And what interfaces are defined and what constraints apply? So here, the requirements model must achieve three primary objectives. Let's see what are the objectives. First objective is to describe what the customer requires, then to establish a basis for the creation of a software design, and to define a set of requirements that can be validated once the software is built. Same likewise objectives, we have some analysis rules of thumb. So a number of worthwhile rules of thumb should be followed when creating the analysis model. Here we are only discussing about 6 analysis rules of thumb. So the first rule is the model should focus on requirements that are visible within the problem or business domain. The level of abstraction should be relatively high. Then each element of the requirements model should add to an overall understanding of software requirements and provide insight into the information domain, function, and behavior of the system. That then delay consideration of infrastructure and other non-functional models until design, that is, a database may be required, but the class is necessary to implement it, the functions required to access it, and the behavior that will be exhibited as it is used should be considered only after problem domain analysis has been completed. Then the fourth and rule of thumb is minimize coupling throughout the system. So it is important to represent a relationship between classes and functions. Then be certain that a requirement model provides value to all stakeholders. That means the model should have specific use for specific stakeholders. For example, business stakeholders should use the model to validate requirements. Designers should use the model as a basis for design, etc., etc. Then keep the model as simple as it can be. That is, don't create additional diagrams when they add no new information. So these are the 6 analysis rules of thumb. Now we're moving on to the next topic, that is domain analysis. Okay, analysis pattern often reoccur across many applications within a specific application or business domain. If these patterns are defined and categorized in a manner that allows you to recognize and apply them to solve common problems, so this improves time to market and reduces development cost. Software domain analysis is the identification, analysis, and specification of common requirements from a specific application domain, typically for reuse on multiple projects within that application domain. So it is important that the goal of domain analysis is to find or create those analysis classes and analysis pattern that are broadly applicable so that they may be reused. So reuse is the main factor here. Then domain analysis may be viewed as an umbrella activity for the software process. That is, it is an ongoing software engineering activity, but not connected to any one specific software project. The role of the domain analyst is to discover and define analysis pattern, analysis classes, and related information that may be used by many people working on similar applications. Now there is a figure which illustrates key inputs and outputs for the domain analysis process. Sources of domain knowledge are surveyed in an attempt to identify objects that can be reused across the domain. So here there is a technical literature, existing application, customer surveys, expert advice, and current or future requirements which is being passed to the domain analysis, and the domain analyst creates class taxonomies, reuse standards, functional models, domain languages to create a domain analysis model. And our next topic is requirements modeling approaches. One view of requirements modeling, called the structured analysis, considers data and the processes that transform the data as separate entities. So data objects are modeled in a way that defines their attributes and relationships. Processes that manipulate data objects are modeled in a manner that shows how they transform data as data objects flow through the system. A second approach to analysis modeling, called object-oriented analysis, focuses on the definition of classes and the manner in which they collaborate with one another to effect customer requirements. So here UML and the unified processes are the object-oriented patterns. Let's see a figure based on requirement modeling. Okay. Each element of the requirements model presents the problem from a different point of view. So we have the first one, that is scenario-based models. See, scenario-based models, which depicts how the user interacts with the system and the specific sequence of activities that occur as the software is used. Then we have class-based elements model, the objects that the system will manipulate, the operation that will be applied to the objects to effect the manipulation, relationships between the objects, and the collaborations that occur between the classes that are defined. We have the third one, that is behavioral elements, depict how external events change the state of the system or the classes that reside within it. Finally, we have flow-oriented elements, which represent the system as an information transform, depicting how objects are transformed as they flow through various system functions. But only those modeling elements that add value to the model should be used. So with these topics, we have come to an end of second unit of our course. I hope you all have understood today's episode. Thank you. Thank you so much for listening.